So again, katong strain sa concrete, 0.003. And tensile strength of concrete shall be neglected in flexural and axial strength calculation. Since for today's topic, we'll tackle flexural strength. So, i-neglect daw ang tensile sa concrete. So again, ang tensile kay below sa neutral axis, therefore, i-neglect ni nato na part. So, same sa example gari na katong sample ruler, then mag-apply ka og load. Then mo tend siya na mo bend ang ruler. Then if mag-analyze ka og sa diri na part, maing-ani siya pag-bend. Then if mo ni mo neutral axis, so mapansin nimo diri kay na compress bitaw siya. So diri kay compression, pag diri kay nainat siya, so tension in a part. So that is why ang below sa neutral axis tension, sa above is compression. So gi-erase na kay gineglect. Then the equivalent rectangular concrete stress distribution in accordance with sections 422.2.4.1 through kani satisfy section 422.2.2.3. So, kung kani siya na section, imong i-side view, mo ni imong makita. And naa siya with sa concrete stress equivalent to 0.85 FC prime. Then, kanang 0.85 FC prime, according siya sa code, shall be assumed uniformly distributed over an equivalent compression zone bounded by edges of the cross-section and aligned parallel to the neutral axis, located a distance A from the fiber of maximum compressive strain as calculated. So 0.85 SC prime, thus uniformly distributed, bounded sa edges. And if mo ning neutral axis o parallel po daw sa neutral axis, then dapat measured ka og A. And kaning A, which is the depth of the equivalent stress block, is equal to beta 1 times C. So ang A from extreme compression padulong diri. So ang C is the distance from the fiber of maximum compressive strain to the neutral axis and shall be measured perpendicular to the neutral axis. So mo ni ang C, extreme compression fiber to neutral axis. And table 422.2.4.3 is the values of beta 1 for equivalent rectangular concrete stress distribution. So, ang beta 1 kay ga-depend kung pila imong FC prime. So, kung in between 17 and 28.85, kung in between 28 and 56, i-solve nimo. Then, kung greater than 56.65 ang beta 1. So for non-pre-stress bars and wires, the stress below Fy shall be Es times steel strain for strain greater than that corresponding to Fy. Stress shall be considered independent of strain and equal to Fy. And the modulus of elasticity E sub S for non-pre-stress bars and wires shall be permitted to be taken as 200,000 MPa. So, gihatag na sa code ang value sa modulus of elasticity, which is 200,000 MPa or 200 gigapascals. So, since from dere to dere is d prime, and we want distance dere to dere, so i-minus na to ang c sa d prime. So, we have that. And this distance is just effective depth minus c. So, gikan sa strain diagram, maka-derive ta og formula. So, by ratio and proportion, so, kani strain sa tension over d minus c is equal to strain sa concrete over c. And from katong E is stress over strain, rearranging, E is stress over modulus of elasticity, and gi-substitute ra siya diri. And solving for Fs, you will get 600 d minus c over c. So, gisimplify ra niyo. And here na po, another ratio and proportion. We have strain sa compression reinforcement, ESC, over C minus D prime equal to strain sa concrete over C. Same rat pod na nag-substitute siya. Equivalent sa strain is stress over modulus of elasticity. And rearranging, you will have compression steel stress Fs prime is equal to 600 times C minus D prime all over C. So, if makalimot ka ning formulas, pwede ra nimo i-derive using the strain diagram. So, after sa strain diagram, we'll discuss the stress diagram. So, ganina sa code, naa daw kay equivalent na concrete stress block na 0.85 FC prime. And para makuha nimo ang force, stress times area ra siya. So, muna yung stress 0.85 FC prime, then times sa area sa concrete. Kaning yellow portion. O napod tay tensile force due to the tensile reinforcement equal to force times stress times area ra Japon. Area sa steel reinforcement times tension steel stress. And napod tay compressive force due to the compressive steel reinforcement. AS prime times Fs prime. So, ano sa code na kung ang Fs daw nimo kay mas gamay sa imong Fy, ang gamiton nimo na Fs kay ang actual niya na actual na strain times Es. So, shall be Es times steel strain. Pero kung imong Fs kay greater than or equal sa Fy, stress shall be considered independent of strain and equal to Fy. So, ang imong gamiton na Fs kay equal to Fy. So, for singly reinforced rectangular beam, Mag-assume ta na tension steel yield, so Fs is equal to Fy. So we have area of the tension steel, neutral axis, width of the beam, effective depth, depth of equivalence test block, distance to neutral axis, and ganina na stress diagram. So ganina kay 0.85 AC prime times area sa concrete. Then, ang area sa concrete kay is just gani siya, which is A times beam width. Tensile force and distance sa compressive force due to concrete o tensile force is just D minus A over 2. A over 2 siya since ang centered kay nara sa ito nga half. And maka-create siya og moment, which is counterclockwise moment. So if we take up summation of force horizontal equal to 0, so we have CC equal to T. And substitute na to ang kanis sa CC o ang T. And rearranging by isolating A, we get ASFY over 0.85 FC prime BW. And if we multiply the numerator and denominator by D, which is just equal na murag mag-times ka 1. So we have this. And if we let rho equal to AS over BWD, and also this rho is also called the reinforced steel ratio or reinforcement ratio. Ratio sa area sa steel to area sa concrete. Effective area. And, di ba, muna siya ang rho AS BWD. So, ang mabilin is katong rho FYD over 0.85 FC prime. And if we let omega equal to rho Fy over FC prime, and Ganisad is also called reinforcement index. Rho Fy over FC prime. So, mas na-simplify pa siya. So, we have omega D over 0.85. So, if we take the value sa aning Mn, pwede siya mag-moment ka dire sa tension. So, mutuyok ang CC, then ang moment arm kay D minus A over 2. Or pwede sad na diri ka mag-moment sa CC, o ang T na sad ang mutuyok with the same moment arm. So, Mn is equals to 0.85 Fc prime ABW times D minus A over 2. And kung kaning T ang gamiton, may mo siyang ASFY times D minus A over 2. And let A equal to omega D over 0.85. Kanira siya. So, substitute ni mo diri. And rearranging, you have FC prime times omega times BWD squared times 1 minus 0.59 omega. And if you let Rn equal to a C prime omega times 1 minus 0.59 omega, and Rn is also known as the coefficient of resistance. And you have Mn equals Rn BWD squared, which is the nominal moment capacity. And for the design, we have phi Mn, i-multiply na siya phi for the reduction factor, so that we will have the design moment capacity. So instead na inani, pwede ra na kanira inyong gamiton. Kay for some, masayon ni siya kay murag gabi sa bitaw kaaning stress diagram. Pero sometimes, tsada Japon ni if murag given na bitaw da ng RN or mas shorter siya. And we also have the formula of the actual steel ratio equal to 0.85 SC prime over Fy multiplied by the quantity of 1 minus square root of the quantity of 1 minus 2 Rn over 0.85 Fc prime. So, kaninid ni i-memorize. So, as mentioned ganina na ay ginatawag na compression controlled o tension controlled section. O sometimes a problem na ipasolve ka for katong dito sa mga limits like at balance condition, at maximum, or tension controlled. So, ato silang i-run through karon. So, for balance condition, again, sa balance condition is dungan moabot ang concrete strain o reinforcement strain sa ilang limit. And we have the distance from extreme compression fiber to neutral axis, CB, at balance condition. And this distance is D minus CB. And by ratio and proportion, CB over 0.003 equal to D minus CB equal all over Fy over 200,000. We'll get the value of CB 600T over 600 plus Fy. And from the code, A is equal to beta 1C. And rearranging, you get C equals to A over beta 1. And sa na-derive ganina, A is equal to rho FYD over 0.85 as C prime. And isolating C, or i-equate nimo ni siya sa beta 1C, o i-isolate nimo ang C, you get rho FYD over 0.85 FC prime times beta 1. And equating sa nakuha nimo na C balance 600D over 600 plus Fy, i-equate nimo ani. And you'll derive your rho balance equal to 0.85 as C prime beta 1 600 over Fy 600 plus Fy. So, ang pattern ani is murag kani siya kay gabalik-balik ni siya 0.85 as C prime beta 1 over Fy. Then kani kay gikan ra sa katong C bitaw. Pero walaon lang hindi. So 600 over 600 plus Fy. And for the maximum condition, when strain is equal to 0.004, we have C max. And by ratio and proportion, same na gyapon. You'll get C max equal to 3 over 7D. And same ra gyapon na i-equate ra ni na C sa imo ang C max o i-isolate nimo ang rho para makuha nimo rho max which is equal to 3/7 0.85 SC prime beta 1 over Fy. So same pattern ra tong 0.85 SC prime beta 1 over Fy tas multiplied ra tong C na giwala lang ang D. So 3/7. So for maximum tension steel and tension controlled, ang reduction factor is 0.9. So we have CT. Strain sa tension controlled is at least 0.005. So by ratio and proportion, you get CT equals 3/8D. And by equating this C to your CT and isolating rho to get rho T, you have 3/8 0.85 SC prime beta 1 over Fy. So this time 3/8 siya. Huwag gatong repeating na 0.85 SC prime beta 1 over Fy. So for the reinforcement limits, the minimum flexural reinforcement in non-pre-stress beams, a minimum area of flexural reinforcement, AS-min, shall be provided at every section where tension reinforcement is required by analysis. AS-min shall be greater of A and B except as provided in section 409.6.1.3 for a statically determinate beam with a flange in tension. The value of BW shall be the lesser of BF and twice the BW. So AS-min is greater of tani A 0.25 square root of FC prime over Fy or sa 1.4 over Fy. And if we equate nimo ning duha 0.25 square root of FC prime over Fy equal 1.4 over Fy, and you solve for the value of FC prime, you'll get 31.36 MPa. So if para dili nakasigig check sa duha, timan-an lang nimo ang 31.36 MPa. And if imo FC prime is greater than or equal to 31.36, kani siya ang mo-govern. And if less than siya, kani po siya ang mo-govern. But since natay calcu, pwede ra na inani nimo i-input using the mean na function. For the analysis or investigation of singly reinforced rectangular beam. So, muna ang first case, medyo gamay-gamay lang ang tension steel area. So, kaning bar, ga-indicate kung pila ang tension steel area. So, since gamay pa man siya, so duwa lang sa diri. And sa kanina case, imong actual rho kay greater than or equal sa minimum na rho. And this minimum rho kay makuha ra tong AS-min. So next case, medyo nisaka na ang bar. So nitulo na ang tension steel. So ang rho nimo less than siya, greater than gyapon siya sa rho min, pero less than gyapon siya sa rho sa tension control. So manotice ninyo murag mo shift pod ang neutral axis kay since madugagan man ang reinforcement, murag mo baba siya kay Mabira siya since nagdugang man ka didto. So like ani niubos siya. Malay pod imo ang kuan strain diagram since depende pod siya aning neutral axis. Kay proportional man siya from neutral axis. So nalay na pod naupat na naghan na ang tension seal area. And actual rho is equal na siya sa tension control na rho. And pa-increase pod. So 5 na kabuok. And rho is greater than na sa tension control. So kanina case is transition na siya sa transition zone. Greater than siya sa tension controlled na rho but less than sa compression control. And here, gi-change another way para mo dako yung tension steel area is padak-an pa imong diameter sa bars. So here, antod ni abot na siya na equal na siya sa rho balance. So compression controlled na ni siya na case. And kani even greater than the rho balance. Still, naagyapon sa compression controlled na zone. So in summary, for this graph is only applicable for singly reinforced rectangular beams only. Rectangular lang since nag-apply na ka og beta 1 ug ang basis nimo sa pag-determine kung asa siya na belong na zone is ang rho. And rho na siya beta 1 sa iyang formula. So here sa left side is first ang compression controlled na zone wherein ang tension steel does not yield and rho is greater than or equal to rho balance. And kanina boundary or limit mo ni siya ang rho balance. So kung mas dako imong rho, dito siya sa compression control. So bali po siya sa strain kay kung ang imong strain kay mas gamay sa strain sa balance condition, compression control. Pero sa rho, kung mas dako imong rho, sa balance condition, compression control. And here na boundary is sa tension controlled na rho. And if imo ang rho is less than or equal to the tension controlled na rho, you have naa ka sa tension controlled na zone and imong tension steel kay nag-yield. And in between sa ila, if in between siya sa rho balance o rho peak, naa ka sa tension, transition zone. And here, nag-yield gyapon imong tension steel. So, gikan diri sa balance, padera, nag-yield na imong tension steel. And here, padulong dito kay wala. So, we also have here over-enforce o under-enforce. So, ito pasawot ana. What do you think ang mas safe? Over-enforce ba na beam or under-enforce? Try the answer sa chat. So, ayun, under, over, napoy under. So, thank you sa response. Kung mag-design daw ta og beam, it's safer na dito ta sa under reinforced. Kay ngano man. So, sa ato ang beam, natay mainly duwa ka material na ay concrete o na ay steel. Imong kabilya. So, kung mag-fill imong concrete, di ba ang concrete is strong in compression? O kung mag-fill na siya, kuan di ba brittle siya, so magdiretso bitaw siya magbungkag. While ang steel, kung mag-fill ang steel, dili siya diretso break bitaw, mo yield pa siya or kanang moadto sa yield point or katong permanent bitaw na deformation. So, kung ka-remember mo na atoy stress strain na diagram bitaw na ay proportional limit hantod sa yield point, tas meron siya ana man siguro to. Ayan, basta, nana. So, diri, naaya ang yield point dira. So, dili, bitaw siya diretso adto siya ultimate strength na ma-break. So, it's better na una yield atong steel para kung siya una yield, makanotice pa ta og kanang cracks bitaw nang mohawid pa siya sa sa structure, dili siya diretso mag-collapse. So, wherein kung ang concrete una, wala. lubong tanan. Walay warnings. So, diretso jud siya. So, kung mag-design ta, diri jud ta sa under reinforced. And kani po na graph is for singly reinforced beams, but pwede siya any shapes like T-beams, triangular, circular. Kung kanina in terms sa row, kani in terms sa C. So, same ra gyapon. Diri kay sa balance, diri sa tension, control, then transition sa tunga. So, we have arrived at our first problem. Given the following data of singly reinforced rectangular beam width is 250 mm, effective depth is 430 mm, concrete strength is 34 MPa, steel strength is 417 MPa. We have to compute the design moment strength in kilonewton meter under the following conditions. So, for the first part, given ang AS, ang tension bars daw kay 6 ka 20 mm. Since we have our FC prime na 34 MPa, i-identify nato first ang beta 1. Since greater siya sa 28 MPa, magamit ta atong formula. Sa slide 16. So here, value sa beta 1, since in between siya sa 28 and 56, ang atwang FC prime, so we have to use this. 0.85 minus 0.05 over 7 times the quantity of FC prime, which is 34 minus 28. Solving, we get 0.807. And here is the illustration of the beam cross-section with its stress diagram. With a width of 250 and effective depth given for 30. So, karon na natay beta 1 and then kuha na to tong mga raw sa katong boundaries like sa raw balance o raw na tension control para ma-compare na to later kung asa siya na belong na zone. So, for tension control, this is the formula 3 over 8 times 0.85 times FC prime, which is 34, times beta 1 na nasolve kanina, 0.807, all over Fy na 415. So we have rho sa tension controlled is 0.02108. And for rho balance, same siya diri na part, but kani lang siya ang nalahi. So for magikan na tong C balance without the effective depth. So 0.85 times FC prime na 34 times beta 1 na 0.807 times 600 over Fy na 415 times 600 plus 415. And we get our raw balance na 0.03323. So, copy lang nato ang values na nakuha. And for part 1, since given ang ES 6K 20 mm, and since ang ato ang reinforcement bars kay circular, so para makuha ang area is just the area sa circle, pi over 4 d squared, which is ang diameter 20 mm, times 6 kay 6 ka buok, and we get 1,884.956 square millimeters. And based sa ato ang stress diagram, let us sum up moments horizontal equal to 0, CC equals to T, and substituting this 0.85 FC prime ABW equals to ASFS ni siya kay wala pa ta kabalo if nag-yield ang tension bars or wala. Ang solution na like same bitaw atong undergrad on katong sa una sa RC na topic na dagan kay kag-agian bitaw kanang mag-assume pa ka na still yields, then if dili mag-assume solve na pud ka sa FS, solve ka sa C, solve sa FS, solve sa A. Magdagan kay to bitaw agian. So, para mas dali ang solution, we'll use this na ang FS kay minimum sa Fy o sa Fs na formula sa steel stress 600 times D minus C over C. And katong A sa code is just equal to beta 1 times C. So from this, i-substitute ni mo tanan. So 0.85 FC prime, which is given 34, times ang A equal to beta 1C and beta 1 kay 0.807C times width sa beam, which is 250 given, equals to AS, which is dissolved 1,884.956 times minimum taning Fs times Fs, which is just minimum sa Fy o katong formula sa Fs na 600 times D minus C all over C. So, kung i-input na sa calcu, so 0.85 times 34 times 0.807. Ilet na to ang C kay X. So, alpha X close. Then, open na sa 250. Close. Alpha equal 1,884.956 times na siya sa ups 415 and shift comma 600 430 minus alpha x over alpha x. Then shift solve. So, wait lang. Lagi. $85, $34, 0.807. Hanggang sa typo error siya. Wait. 134.165. So, sorry for that. Na-typo error. So, we get a C of 134.165 and multiplying by beta 1, you'll get A, which is 108.271 mm. And we'll solve for the actual steel ratio using the given AS over BWD. So 1884.956 all over 250 times 430. We have 0.01753. And comparing sa kaning mga boundaries, ang atong actual is less than sa raw na tension controlled. Therefore, nag-yield ang tension still and also naa siya sa tension controlled na zone and we'll use P equals to 0.9. So, to get Mn, moment ka sa CC. So, ASFY times D minus A over 2. So, AS is 1,884.956 times Fy na 415 times 430 minus A na 108.271 all over 2. And you have Mn equal to 294.023 kilonewton meter. And to get the design moment, multiply sa phi na 0.9 and you'll get 264.62 kilonewton meter. For the second part, so nalahi ang size sa tension bar and we have 5 ka 22 mm na tension bar. So same ra ang value sa beta 1 sa row sa tension controlled row o row balance. So we'll solve for AS. Area sa circle o pila ka buok bars is just 1,900.664 square mm. And sum up moment horizontal, CC equals T. And katong Fs is the minimum lang sa Fy og 600 times D minus C over C. And also using this A equals to beta 1 times C and substituting everything, 0.85 times SC prime na 34 times A na beta 1 times C times 250 equal to 1,900.664 times minimum of 415 and Fs na formula.
Well, it's green. It kind of looks like the Hulk or
So,
something.
try.
Where are the muscles? They're just printed on here. Let me try this on though and see if it makes me look buff. I don't feel any buffer. The fabric is kind of comfortable, but
0.85 times 34 times 0.807 alpha x times 250 equals 1,900.664 times minimum apps 415, shift, close parenthesis, 4 comma, then 600 times 430 minus alpha x over alpha x. Shift solve. 135 point, ang type error na sa 28283. One 35.28. So RC is equal to 135.283 millimeters. And to get A is just beta 1 times C. So 109.173 mm. And rho is just AS over BWD. And this time, na-change ang AS 1,900.664 and we got the actual rho of 0.01768. And comparing na pod sa mga boundaries, mas gamay Japon siya sa tension-controlled na rho. Therefore, tension still yields and tension-controlled siya. So, phi is equal to 0.9. So, solving for the moment, nominal moment, AS is ASFY times D minus A over 2 is just 1,900.664 times 415 times 430 minus 109.173 over 2. So, solving for that, we get 296.117 kilonewton meter. And design man ang gipangita, so multiply na to reduction factor P equals 0.9. And we get our final answer, 266.505 kilonewton meter. So, for part 3, like another na pod na area sa tension steel. Same value sa beta 1, rho T, and rho balance. And area sa tension steel is 2,945.243 square millimeters. And summation of forces horizontal again. Same process lang. So 0.85 times 34.807 alpha C times 250 alpha equals 2945.243 times ups 4 minimum sa 415 comma 600 times 430 minus alpha x over alpha x. $209.632. So, light na sadya. 632. So C is equal to 209.632 mm. And to get A, multiply lang ang C sa beta 1. So A is equal to 169.173 mm. And we'll get the actual raw again. So AS is equal to BW times D. So actual raw is 0.0274. And nilapas na siya sa raw tension. But less than siya sa 0.03 na raw balance. So since in between siya, meaning kaya na siya sa transition zone. So tension still yield since greater siya sa raw balance. And yes, transition zone. And if na siya sa transition zone, need na to i-verify iyang Fs. So Fs is maning formula 600 times D minus E over C. 630.945. Need na to siya ma-check if mababa siya sa Fy na 415. So since wala man, o na-indicate po ganina na ni-yield. So Fy ra Japon ang gamiton. And since na siya sa transition zone, ang phi is katong taas na formula which is 0.65 plus 0.25 Fs minus Fy over 1,000 minus Fy. So, mga na siya. So, instead na kani, pwede ra pod nimo siya ma-mode 3-2. Mura ra siya. Mura kag nag-interpolate. So, example, mode 3-2. So, first i-input nimo is 0.65 katong phi sa compression controlled tas phi sa tension controlled 0.9. O ang Fy din nimo which is 415. Then, ang stress kung tension controlled is 1,000 MPa. And paitaon nimo ang equivalent phi, i-enter nimo ang actual stress which is kani 630.945. Then ups 8 then ka og x hat. So 0.742. So same ra Japon imong makuha. So mo ni ang values na na-solve. And now we can now solve for the nominal moment capacity, which is equal to ASFY times the moment arm. So AS is 2,945 times Fy na 415 times moment arm 430 minus A over 2. Solving for this, we have 422.191 kilonewton meter. And to get the design moment strength, i-multiply lang sa phi na nakuha, which is 0.742. And we have our final answer, 313.385 kilonewton meter. So, letter B. So, for part 4, same process. Magwa ta sa tension steel area, 4,926.017 square mm. Same Japon namang summation force horizontal based sa stress diagram. And using these formulas, We'll solve for C. Point 85 times 34, 0.807 alpha x, 250 alpha equals 4926.017 times minimum. Oops. Ay, naka-mode 3 to. Hindi. Balik sa mode 1. 0.85, 34, 0.807, 250, 4926.017 ups 415. 600 times 430 minus alpha x over alpha x. Two 277.781. To get A, i-multiply sa beta 1. So, A is 224.169. And rho is just equal to AS over BWD. So, rho is 0.04582. And nilapas na siya sa rho balance, meaning na siya sa compression controlled section. So, ang tension still wala nag-yield. And we'll use phi equal to 0.65. And we'll solve for Fs 600 times D minus C over C. We get 328.832. Since less than siya sa Fy, ang atong gamiton na Fs is kani siya na Fs. So, solving for Mn, ASFS na siya. Since less than siya sa Fy, times D 430 minus 224.169 over 2. So we have Mn is 514.945 kilonewton meter. Times phi na 0.65. So our final answer is 334.715 kilonewton meter. Letter D. And now for the analysis sa doubly reinforced rectangular beam. So similar ra siya sa singly reinforced but karon nanay steel reinforcement sa compression side. And ang strain niya is ES prime. So sa kanina case, gamay-gamay pa ang tension steel area and ang tension steel nag-yield but ang compression steel kay wala nag-yield. So inani na case na either sa isa ang mag-yield. So if we increase ang tension steel area, same ra Japon, tension steel yield pero ang compression steel wala nag-yield. And hantod maabot sa point na sila duwa ang tension steel o compression steel kay nag-yield. And naapoy case na ang tension steel kay wala nag-yield but ang compression steel nag-yield. And delikado kayo if both sila wala nag-yield kay meaning una ang concrete mag-fail. So either sa duwa or sila duwa ang mag-yield dapat. So for our problem, given the following data of a rectangular beam dimensions B is 300, H is 570, compression bars diameter 20, effective cover to the centroid of bar 70, FC prime is 28, Fy is 415, number of compression bars is 4, and we have to compute the nominal moment capacity. So, isa sa timailhan din na analysis, ang problem is given na ang AS or ang steel reinforcement tas paitaon ang capacity and reverse pod sa design given na ang moment tas paitaon nimo ang number of bars. So, mo ni iya ang SAS diagram. And for the tulo ka situation, same ra sila og compression bars na given, which is 4 na diameter na 20 mm. So, we'll solve that first. We have AS prime is 1,256.637 square mm. So, for the first problem under situation, using 4 ka 28 mm tension bars, compute the ultimate moment capacity. So, AS prime kanina is 1,256. And since our FC prime is just equal to 28, our beta 1 will be 0.85. So, sa part 1, given ang 4 ka 28, and if we solve for its area, we have 2,463.009 square mm. And same ra Japon, mag-summation of force horizontal, but tulo na ka forces involved aside sa compression due to concrete and tension due to the tension steel. We now have an additional na compression due to the compression steel. And katong compression due to the compression steel is equal to AS prime times FS prime. So, substitute here, apil ang ASFS sa T og 0.85 LC prime ABW sa CC. And same ra gyapon na ang Fs is just ang minimum sa Fy o sa Fs na formula, 600 times d minus c over c. And for Fs prime, minimum ra sa Fy o sa Fs prime na formula, which is 600 times c minus d prime over c, which is ang kanidua kay na-derive ganina. And A is equal to beta 1 times C according sa code. And by substituting everything para makuha si C, so try na to. Two, 4, 6, 8.009 times minimum. So 415, 600 times 500 na D minus C alpha X all over alpha X close parenthesis minus 0.85 times 28 times 0.85 alpha X times 300 minus 1256.637 times minimum of Fy and 600 alpha X minus 70 over alpha X. So we have 117.929 nasakto ra jud millimeters. And to get A, multiply by beta 1, and A is 100.24 millimeters. So, katong na-solve ganina. And solving for Fs, i-substitute lang ang nakuha na C o ang effective depth na 500. We have 1,943 and greater siya sa 1,000 MPa. Therefore, na siya sa tension controlled o ni-yield ang steel since greater siya sa Fy na 415. So, we'll use phi equal to 0.9. So, for Fs prime, substitute ang nakuha na C, and D prime is just extreme compression fiber to centroid sa compression steel, which is 70. And we get Fs prime is 243.854, which is less than sa Fy, therefore wala ni yield ang compression steel. And let's solve for Mn. So, mag-moment ta here sa T, tas mutuyok ang CC o CS prime. And mo ilang moment arm for CC is same ra D minus A over 2. And moment arm sa CS prime is just D minus D prime. So, substituting, FC prime is 28, A is 100.24, beam width is 300, AS prime is 1,256.637 times Fs prime times d minus d prime. And we have Mn equals to 453.752 kilonewton meter. And multiplied by 0.9, we have our final answer 408.377 kilonewton meters. So for part 2, same process. So we'll solve again for AS, which is 3,694.513 square mm. And again, mag-summation for horizontal. And using these formulas, og i-substitute aning main equation to get C. And shift solve, we have 177.400 round up to 415 mm na C. And to get A, multiply sa beta 1. And we have A equals to 150.802 mm. So copy. And solving for Fs, 600 times d minus c over c, we have 1,090.955 MPa. So greater gyapon siya sa 1,000, therefore tension controlled. O greater pod siya sa Fy, meaning nag-yield. So phi gyapon is 0.9. And for Fs prime, 363, less than gyapon sa Fy, so wala ni yield. And to solve for Mn, moment sa T, so 0.85, Fc prime na 28, A na 150.802, beam width na 300, effective depth 500 minus A over 2 plus AS prime na 1,256.637 multiplied by Fs prime na 363.266 times D 500 minus D prime na 70. So we have Mn is 653.47 kilonewton meter. So multiplied by phi to get the design moment capacity, which is just equal to the ultimate moment capacity, is 588.123 kilonewton meter. So sa part 3, same process Japon, kuha sa AS, 4,825.486 square mm. Summation of force horizontal to get this equation. And using these and substitute, you'll get C equals to 244.039 millimeters multiplied by beta 1 to get A, which is 207.433 mm. And so for Fs again, and here we notice na less than na siya sa 1,000 MPa, therefore dili na siya tension controlled. But greater than sa Fy na 415, so ni-yield ang steel. In between siya sa balance o sa tension controlled, so it is na siya sa transition zone. And our Fs prime is 427.896 MPa. And we notice na this time, mas dako na jud siya sa Fy. So, giyag ang compression steel. So, since nasa transition zone, mag-solve ta for phi, 0.65 plus 0.25, Fs minus Fy all over 1,000 minus Fy or mag-mod 32 ka, you'll get 0.742 na phi. So, solving for Mn is same ra, mag-moment yapon ka sa T. So, 0.85 times Fc prime times A na 207.433 times beam width 300 times 500 minus 207.433 over 2 plus AS prime na 1,256.637 times Fy na 415 times D 500 minus D prime 70. So our Mn is 811.171 kilonewton meter multiplied by phi, and our final answer is 601.554 kilonewton meter. So for the design sa reinforced concrete beam, gi- uh, given na pod ang MU or design moment capacity or ultimate moment capacity or ipasolve ka sa moment, maximum moment, then papangitaon din ka sa number of bars. So design, so ikaw magbuot kung unsa dapat ang number of bars, but based Japon siya sa code. So for this first case, singly reinforced pa siya since ang ato ang tension reinforcement kay tension reinforcement pa ang naa og wala pay compression steel. So sa kaning bar sa left, ga-indicate na po siya sa required strength. So since gamay ra man ang required strength, gamay ra ang needed na bars. And if modako na ang required na strength, managhan ang needed na bar, so nag-add ta og bar. And singly reinforced pa Japon siya. Antod magkadako na sad. And moabot sa point na dili na ta ka-add og daghan pa na reinforcement diri since naaman to'y mga minimum base sa code og dapat pod ang imuang tension na bars kay ka-follow sa katong tension controlled na moment. Then if molapas siya ato sa tension controlled na moment capacity, need nimo mag-add na og doble ay compression steel and may mo na siya doble reinforced na beam. So for the problem is given the following data of a rectangular beam. The beam dimension 300 by 610. The tension bar is 25, compression bar is 20. Tension steel is 90 mm, compression steel is 60. And the strength of the main bars is 415 MPa or monang Fy. Ang sa ties kay 275 MPa. Concrete strength is 27.5 MPa. And we need to compute the required number of tension bars under the following factored moments. So here is the cross-section of the beam. Given the dimension of effective cover to centroid of bars. So ang cover kay diri padulong sa centroid, so 90. And para makuha ang effective depth, i-minus lang ang beam height sa katong effective cover. So, we have 520 mm effective depth. First, solve for phi MNT to check if the beam's capacity is sufficient to resist the required moment for singly reinforced beam. If not, we may put rebars in the compression side for doubly reinforced beam. So again, solve for MNT, phi MNT, and if malapas siya, doubly reinforced, and if equal or less than lang, singly reinforced. So, mag-start ta sa CT para makuha ang VMNT, which is equal to C over 8D. And 80 is beta 1 times CT. And MNT is 0.85 FC prime 80. So, katong CC times moment arm na D minus A over 2. And since tension controlled siya, 0.9 ang phi. So, muni ang criteria again. So, solving for MNT, so 3 over 8 times effective depth na 520. CT is 195. Multiplied by beta 1 to get 80. We have 165.75. So, phi MNT is 0.85 times SC prime na 27.5 times 165.75 times 300 times 520 minus 165.75 over 2. Multiplied phi to get the phi MNT. We have 457.27 kilonewton meter. So, mo ni atong basis kung singly siya or doubly. And for part 1, 150 kilonewton meter. So, less than ra siya sa VMNT. Therefore, singly reinforced ra siya. And katong alternate na formula sa VMN or MU is V RN BWD squared. So, rearranging, we have Rn is just mu over phi bd squared. So, substitute the given 150 times 10 raised to 6 to convert to Newton mm over 0.9 times 300 times d na 520 squared. So, Rn is 2.055 MPa. And we'll use this formula of the actuosity ratio. Substituting FC prime, Fy, Rn, and again FC prime. We have actuosity ratio of 0.00519. But mag-check ta sa minimum na row. So, kato ganina, gi-equate ang duha and we get 31.36. So, asa man dere na belong ang kanina case. So, since atong FC prime kay 27.5, less than ra siya sa 31.36, therefore, kani ang mo govern 1.4 over Fy. So, we have bromine is 0.00337, and we have to choose larger sa raw actual o sa raw minimum. So, the larger is 0.00519. And rearranging sa katong row na formula, AS over BWD, tas cross multiply. So, we have AS equals rho BWD. So, substitute ang nakuha. Wait lang, guys. So, balik ta. We'll use this greater na value sa row, 0.00519, and substitute sa row BWD to get AS. And we have AS is equal to 809.62 square mm. And to get the number of bars, we'll just divide the required steel area sa bar. And sa given, ang tension bars should be 25 mm. So we'll use that one. And we get 1.649. But wala may 0.649 na bar. So mag-round up ta. So let's say 2 bars. So letter D. So for part 2, same process but lahi na ang MU. And if we compare it sa VMNT to determine if singly reinforced or doubly reinforced, since less than siya sa VMNT, therefore singly reinforced Japon atong beam. And solving for Rn, MU na 400 times 10 raised to 6 to convert to Newton mm over phi 0.9 times BW 300 times D squared. We'll have Rn is 5.479 MPa. And solving for the actual steel ratio, by using this formula, we have actual steel ratio of 0.01527. And same raman ang FC prime 27.5. So kanila Japan ang mag-govern na rho mean 1.4 over Fy. And we'll choose the larger of the two. So we'll use 0.01527, the actual rho. So to get AS is just rho BWD. And AS is 2,382.533 square millimeters. And to get the number of bars, divide that by the area of the bar, 25 mm diameter. And we'll get 4.854. So rounding up, let's say 5 bars. So we'll choose letter A. And for the third part, by 650 kN. And we notice na mas dako na siya sa VMNT. Therefore, doubly reinforced na siya. And for doubly reinforced beam, if mao ni ang cross-section sa beam, Mn ang iyang nominal moment capacity, equal ra siya sa ang first part is Mn1, which is just equal to Mnt, or the tension controlled na moment, plus Mn2, which is combination sa AS2 o AS prime. But first, let's solve for this, ang Mn. So since Mu is less than or equal to phi Mn, and if isolve na to ang Mn, divide both sides by phi. So Mn is just Mu over phi. So 650 over 0.9. And Mn is 722.222 kN/meter. So at this figure 1, summation of force horizontal, so Cc equals T, T1. So we have 0.85 Fc prime, A, T, kay tension controlled man ni tanan sa figure 1. times BW equals to AS1 FY. And FY na siya automatic here sa figure 1 since tension controlled man and tension controlled kay ga-yield ang steel. So 0.5 SC prime 27.5 times 80 na 165.75 times 300 over 415. So AS1 is 2,800 square mm. So to get Mn2, i-isolate lang siya, i-transpose ang Mn1. So Mn2 is Mn minus Mn1 and Mn1 is just Mnt. So Mn2 is Mn 422.222 minus Mnt na 508.08. We have Mn2 na 214.142 kilonewton meter. So, copy lang sa na-solve ganina. And here, diri na punta sa figure 2. Mag-sum up moment equal to 0. So, mag-moment diri sa CS prime. So, AS2 FY times D minus D prime. So, here, nag-assume lang sa na mo yield. So, FY ang gigamit. So, Mn2 times 10 raised to 6 to convert to Newton mm equal to AS2 times FY na 415 times 520 minus 60. And we have AS2 na 1,121 square mm. And since natay AS1 o AS2, i-add lang sila duwa to get AS. So we have 3,922 square mm. And to get the number of bars, divide AS by area sa bar. And we have 7.91 or let's say 8 bars. But napatay compression bar since doubly reinforced o i-check po na to if niyield bagid ang compression bars. So to check, let's compute for Fs prime. And Fs prime is 415.385 MPa. So igo-igo lang jud siya na niyield. So use Fs prime equals to Fy. And here's a figure 2, summation of force horizontal para makuha na to ang AS prime. So CS prime equals T2. So since ni-yield siya atong Fs prime kay Fy, since same sila na Fy both sides, i-cancel lang na to. So AS prime is just AS2. And AS2 is 1,121 divided by the area of bar to get the number of bars. And let's say 4 bars. Ang compression bars na to. So that's it for RCD Flexural. Napatay next topic which is shear. RCD shear. But before that, basing na po may questions. Mag-start lang ta mga 8 PM siguro sa kuan sa shear. It's already 8 p.m. Let's proceed sa next topic, RCD shear. So let me share my screen. So we'll discuss shear strength, ang one-way shear strength. So here's a background. Makabantay mo na ay ginamit na ano, reinforcement para sa beam. And if mo ni ang longitudinal bars, kaning nag-wrap around mo na siya ang gitawag na shear reinforcement. And if sa beam siya, ang tawag kay stirrups. And if column siya na shear reinforcement, ang tawag kay ties. So for this code, for each applicable factored load combination, design strength at all sections shall satisfy V S sub n greater than or equal to U. So, tanan na design capacity, dapat mas dako siya or equal sa ultimate capacity. So, applicable sa moment, sa shear, sa torsion, o sa axial force. Dapat greater than or equal ang design kaysa sa mga ultimate. And phi or the reduction factor shall be determined in accordance with section 421.2. So this is table 421.2.1 or the table of the strength reduction factors. And we're interested karon sa shear. And the phi for shear is 0.75. And same sa present ganina katong strength reduction factor for moment, axial force, or combined moment and axial force. So for beams built integrally with supports, VU at the support shall be permitted to be calculated at the face of support. Sections between the face of support and a critical section located D from the face of support for non-pre-stressed beams and H/2 from the face of support for pre-stressed beams shall be permitted to be designed for VU at a critical section if A through C are satisfied. So, dapat ang support reaction in the direction of applied shear introduces compression into the end region of the beam. Loads are applied at or near the top surface of the beam and no concentrated load occurs between the face of support and critical section. So, muna ang conditions para pwede ka magamit sa shear sa square root of FC prime BWD. It is lesser of D/2 or 600 sa non-prestressed beams and D/4 then or 300 if greater than siya. So for our first problem, given the following data of a rectangular beam, width is 250, effective depth is 450, and the span of 8 meters, and we are given the service dead load of 28 kilonewton meter, including na ang beam weight, and live load of 35 kilonewton per meter, and stirrups or the transverse reinforcement diameter is 10 mm with a yield strength FYH equals to 275 MPa. So, usay FYT ni siya, usay FYH ang ginagamit. So, concrete strength is FC prime 21 MPa. So, simple span, simple support na IP na eye roller, then uniform distributed na load, denoted by WU, and span of 8 meters. And we'll solve for the reaction. But first, let's get the factored total uniform load. And the load combination na atong gamiton is the common one, which is 1.2 dead load plus 1.6 live load. Substituting the given, we have a factored total uniform load of 89.6 kilonewton per meter. And now that we have it, we can solve for the reaction. And by symmetry, since symmetrical raman, so ang reaction diri kay same ra sa reaction diri. So W times L, i-divide lang sa 2. So ang R is 358.4 kilonewton. So if mag-draw ta sa iyang shear diagram, so since pasaka, we have 358.4, then napod na diya 358.4 po diri. And katong critical section from face of the support atras kaog D distance, which is the critical section for shear. And kaon na to iya ang equivalent na VU. So to get that, mag-cut ta diri sa D distance. So kani ang atong makita. Since nag-cut ta na ay internal na force VU. And para makuha ang VU, mag-sum up force ta vertical. So VU plus WU times D minus R equals 0. So tanan down positive, ang upward negative. So isolating VU and substitute ang nakuha na R o WU o D. Ang effective depth kay 450 mm, i-convert to meters, so 0.45. And we have VU equals to 318.08 kilonewton. And we can solve for the shear strength provided by concrete. Since ang shear strength kay naay sa concrete VC o napoy VS, so i-add sila multiplied by phi. Equal siya sa VU. So ang VC is 0.17 lambda square root of FC prime BWD as per the code. So ang lambda is equal to 1.04 normal weight concrete. So unless stated na lightweight concrete, mag-assume ta na normal weight siya. So 1 atong gamiton. And FC prime is 21. and beam width 250 times effective depth na 450. So we have VC is 87.64 kilonewton. And we also need to check katong sa code na katong VU should be less than or equal to VC plus 0.67 square root of FC prime BWD. Need na to ma-check if adequate ra ba ang iyang dimension. So, substitute ang VC na nakuha. FC prime given ang width of depth. So, ang value niya is 324.8. Then, i-compare sa VU. So, mas gamay ang VU. Therefore, check ra ang dimensions. So, copy. Tanan nakuha. Next, if we need to check if ang VU kay greater than or equal sa VC. Okay, according sa code, kung greater ang VU sa VC, pwede ni magamit na formula VS is greater than or equal to VU over V minus VC. And if dili ni siya masatisfy, dili ni siya pwede magamit ng formula and mag-check ta sa AV minimum. So, VC is V 0.75 for shear times VC nakuha is 87.64. So, VC is 65.73 kilonewton. And mas dako ang VU. Therefore, applicable rin siya na formula. VS equals VU over V minus VC. So, and meaning pod anin sa code is if ang VU kay greater than sa VC, kailangan jud na ay shear reinforcement. So, VU 318.08 over V na 0.75 minus 87.64 is equal to 336.47 kilonewtons. And from the code na formula of VS is AV FYH D over S. And rearranging that to isolate S, we have AV FYH D over VS. And AV kay mo ang area sa shear reinforcement. And ang diameter aning shear reinforcement sa given is 10 millimeters. So here given na 10 mm. And kuan sa kanina figure sa kaning simply supported na beam, ang kanina section is, di ba, critical section, so na siya diri sa D distance and mura na siya ana, tas mo extend siya pa dira. And kani ding reaction kay mo ni iyang direction. So if mo ni siya ang cross section, ang reaction kay padiri siya na direction. And ang basehan nimo para kung pila imong i-multiply sa area sa shear reinforcement para makuha ang AV kay kung pila ka buok ang parallel ani na reaction. So since vertical man siya, so ang parallel niya kay kani isa, kani duwa, og tulo. So tulo ka buok ang parallel. So therefore 3 yung i-multiply sa area sa shear reinforcement para makuha ang AV. So it is equal to 235.6 square mm. So substituting AV times FYH times D over VS, 336.47 kilonewton i-convert to Newton, so times 10 raised to 3. And we have S equals to 86.65 mm. But always jud mag-check sa max spacing. So according atong table ganina, so i-compare na to siya sa 0.33 square root of FC prime BWD if kani ba ang gamiton D over 2 600 or D over 4 or 300. And 0.33 square root of FC prime BWD is equal to 170.13 kilonewton. Since ang BS 336 kay mas dako sa 170, therefore katong D over 4 or 300 greater of D over 4 or 300 ay least of the ay. So since mas gamay man ang D over 4, 112.5, so ang S max nimo kay 112.5. And i-compare pa nimo ang imong S max sa katong na-solve nimo na actual na spacing. And choose smaller in terms sa spacing. Kaya mas kusgan man siya if dikit-dikit ang mga stirrups kaysa dagko og space. So our final answer is 86.65 mm. So next, determine the maximum spacing of stirrups required at 0.2 L from support using 2 legs of stirrups. Sa problem 1, gi-indicate din niya na maximum spacing required near the support. That is why nag-distance ta katong critical section. And gi-mention na din niya kung pila ka legs ang gamiton, which is 3 legs. And here's sa problem 2. I-determine ang spacing sa 0.2 L dili sa critical section of indicated na 2 legs of stirrups. So same ra sila og VC sa part 1 and PVC same ra pod. And check siya atong if required ba na magbutang og shear reinforcement. So since and so here part 2 mag-measure daw ta og 0.2 L. So 0.2 sa 8 meters. And we'll use its VU. So mag-cut ta dire para makuha ang VU. So tanan downward positive kung mag-summation of force vertical and upward negative. And rearranging to get VU, we have R minus WU times 0.2 L. And substituting the R, the WU, and the length 8 meters, we get VU is 215.04 kilonewton. And if i-compare nimo aning kaning gihatag sa code, and VU is less than aning 0.75 VC plus 0.67 square root of FC prime BWD. So, need taog shear reinforcement. And since VU is greater than PVC, applicable ni na formula Vs equals VU over phi minus VC. So VU is 215.04 over 0.75 minus VC 87.64 and Vs is equal to 199.08 kilonewton. And using this formula, we isolate S. So need pa nato og AV and indicated sa problem na using 2 legs of stirrups, so times 2, and the diameter sa stirrups is 10 mm. So ang area sa stirrups is 157.1 square mm. And substitute AV times FYH na given times 415 na depth all over VS na 199.08 times 10 raised to 3. So, careful pod mo kay basing ang mabutang ninyo kay ang FY kay dili always same ang FYH o FY. Since lelay man na bar ang ginagamit. So, since mas gamay ang diameter sa bar sa stirrups, most probably mas gamay pod iyang yield strength. So, always check for max spacing. So, 0.33 square root of FC prime BWD is 170.13. I-compare siya sa VS. Since mas dako ang VS, you'll use katong D over 4, whichever ang smaller sa D over 4 or 300. And D over 4 is 112. So, mas gamay siya sa 300. So, mo siya imong max spacing. But, i-compare po pod nimo sa imong na-solve na actual spacing. And choose smaller. So, mas gamay ang 97.66. So, the final answer is 97.66. And, if magpili ka sa choices, dapat ang pilion nimo kay ang smaller Japon. So, 95, letter D. Smaller siya, but duol-duol ra siya sa final answer. So for part 3, lain na pod ang location na kuhaan nato og VU karon kay 0.35L na. So here mag-cut na pod ta. And to get VU, we'll sum up force vertical. So tanan downward kay positive, upward, negative. And rearranging to get VU. So R 358.4 minus 89.6 times 0.35 sa length na 8 meters. So we get VU is 107.52 kilonewton. And i-compare siya if okay ra ba atong dimension. And if need pa nato og shear reinforcement, we'll compare VU sa PVC. Since greater siya, need na to shear reinforcement. So we'll use this formula. VU is 107.52 over 0.75 minus BC na 87.64. So we have VS is 55.72 kilonewton. And same gyapon na formula, rearrange para makuha ang S. And given na sa problem na 2 legs of stirrup, so times 2 siya sa area sa ato ang shear reinforcement. So AV is 157.1 gyapon square mm. So substitute all the na nakuha. AV 157.1, FYH 275, D is 450, and VS is 55.72 times 10 raised to 3 to convert to Newton, and S is 349 mm. And again, check for max spacing. So 0.33 square root of FC prime BWD is 170.13 kilonewton. And since VS kay mas gamay sa kaning 0.30 something, so ang applicable kay katong D over 2 or 600, whichever is mas gamay. So ang 225 mas gamay sa 600, so ang S max nimo kay 225. And i-compare nimo sa actual na na-solve. So this time, mas gamay ang S max, so choose smaller. So S is 225 mm. So permi jud ta mag-check sa max spacing. Kay if ever diri ra to taman, wala ta kabalo na mas gamay pa man day ang S max. So sayang kay ang 1 point. And for part 4, another location na pod 0.45 L. So hapit na siya magkatunga. So mag-cut ta here to get VU. Sum up force vertical equal to 0. VU plus WU times 0.45 L minus R is equal to 0. Rearranging and isolating VU. And calculating for VU, we get 35.84 kilonewton. And i-check na to if enough ra ang dimension. So, okay, check. VU is less than 0.75 times VC plus 0.67 square root of FC prime BWD. And we also need to check ang half sa PVC kay gamay man jud kay siya ang VU. So, we now know na ang VU nato kay in between na siya sa half sa VBC o VBC. And katong sa code earlier, dili. So, if in between so kung ang imong VU kay less than or equal sa PVC, need nimo mag-compute for minimum area of shear reinforcement. So, we'll use this non-pre-stress beam type and AV mean is greater sa kaning A or kaning B. So, balik ta sa problem. So, we need to solve for AV mean, which is greater of the two. So, substitute ang given FC prime beam width of FYH. And ang greater sa ila kay 0.318 mm. So, kung i-try nimo sa kanon, pwede ra tong max na function kay greater man. So, ups 3.602 062 square root of FC prime FC prime na 21 times 250 over 250 over 275 comma 0.35 times 250 over 275. Point 318. So, since ang VU kay less than na siya sa VVC, so, di ba na-notice po na to ganina na diri dapit sa support, close ra ang kuan, ang spacing, and diri sa hapit na maglayo-layo, magkalayo-layo pod ang iyang spacing hantod mo closer na pod diri dapit sa support. So, ang gakahitabo in actual, since ang kaning location kung asa ta nag-cut kay layo-layo na siya sa support. So, ang spacing niya sad kay lagyo na pod. So, if magamit ka tong formula ganina sa katong S equals AVFYT, ano ba itong D over VS. murag sure na murag dako na gid imong ma-compute na S ana. So morning sa code na if molapas na ka sa kung ang imong view kay in between la sa 0.5 PVC o PVC, mo diretso na lang din ka sa max spacing. So max spacing is D over 2. And it is 225 mm. And kanin din na spacing imong gamiton para diri para makuha ang AB mean. So, ang minimum na shear reinforcement is 71.6 square mm. So, letter A. So, answers of part 1 is A, 85. For part 2, 95. Part 3, 225. And finally, for part 4 is 72. So we have another example. Our rectangular beam is subjected to shear and flexure only. Given the dimensions, effective cover, concrete strength, steel yield strength sa main reinforcement og stirrups. So muna yung giingon kanina na dili mag-equal ang Fy o Fyh. Napoy times na same. Pero dapat jud ka mag-careful kung unsay mong gamiton sa ila adua. And reduction factor is shear is 0.75. So this is the cross section, 350 by 500. And effective cover is 75. So solving for effective depth D is just 500 minus 75, which is 425 mm. And solving for the shear strength provided by concrete, 0.17 lambda squared of FC prime BWD. So 0.17 lambda is 1, FC prime is 27.5, BW is 350, and D is 45. So we have VC 132.61 kilonewton. So if imong i-turn into another perspective, inani imong makita. So for the shear strength provided by steel, Vs is equal to AVFYH D over S. And for part 1, ana siya na if the beam is reinforced with 3 legs of 10 mm diameter stirrups, spaced at 80 mm on centers. So calculate the design shear strength. So given na spacing, given na FYH o na-solve na nato ang D. So mag-solve na ta sa AB. And indicated na 3 legs of 10 mm diameter. So area sa 10 mm diameter times 3 legs. And AB is 235.6 square mm. So substitute and calculating, we get Vs is 344.2 kilonewton. And check if adequate ang dimension. So since ang Vs kay less than ra sa 0.67 square root of FC prime BWD. So, okay ra ang dimension. Then, di ba ganina kay kung man to VC plus gani. But since ang gipangita man kay VV and since di pa na to siya makuha. So, nidiretso na lang siya diri sa VS sa pag-compare. Kaya same naman to phi na VC plus VS. And to get Vn, it's just VC plus VS. So VC is 132.61 and VS is 344.2. So Vn is 476.8 kilonewton. Multiplied by phi na 0.75 for shear. And our final answer is 357.6 kilonewton. And for part 2, given ang shear strength of 390 kilonewton and we need to calculate the spacing of 3 legs of 12 mm stirrups. So, ang shear strength is just VVN equals to 390 kilonewton. And sa criteria sa design is ultimate should be less than or equal sa design. So, para makuha na to ang VU, and VU is just equal to, I should be less than or equal to phi times Vn na VC plus Vs. And if i-rearrange nimo to get Vs, you'll arrive at this. Vs is equal to Vu over phi minus Vc. And Vu is 290 over phi na 0.75 minus Vc na 132.61 and you have Vs equal to 387.39 kilonewton. And check for the adequacy of the dimension. Since Vs is less than sa 0.67 square root of Fc prime BWD. So, check ka siya. And sa code, need na mag-check og inani. But, kung board exam type, ana to ang instructor na pwede na daw na mag-skip ka ni na part since ang problem mismo kay kanang gapapangitaon na bitaw kadaan sa sa shear reinforcement. So, almost always jud siya mapasar ani. So, let's proceed to get the spacing, rearrange yun na formula. And given sa problem na 3 legs of 12 mm stirrups, so area sa 12 mm stirrups times 3. So AV is 339.3 square mm. And we can now substitute everything to get S na 102.3 mm. So for part 3, which of the following gives a maximum spacing of 3 legs of 12 mm diameter stirrups? In part 2, according to 2015 NSCP. So maximum spacing. Also 4.33 square root of Fc prime BWD. And since mas dako ang Vs, we'll use katong D over 4 or 300, whichever is mas gamay. So, ang S max is 106.25 mm, letter C. And I think last problem na ni siya. Okay ra sa inyo mag-extend tagamay. Medyo taas-taas man jud ang topic. Pero last naman sad na problem. So, tiwason na lang ni nato. So, given the following data for the column section shown, dimensions B by H 450 by 600, main bars kay 10 ka 28 mm diameter, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. FY is 415, ties is 12 mm diameter, FYH kay 275 MPa. Concrete strength is 27.5 MPa, spacing of ties 90, reduction factor 75.75, and the clear concrete cover to ties is 40 mm, and the factored axial load of 1,250 kilonewton. So, ang supposedly atong topic is shear strength for beams, but gi-include lang nako ni ang column kay common Japan siya mogawas, and as nag-check ko sa schedule sa REE kay murag dili makover. So, pang additional lang pod. O para pod makabalot ton so to paggamit tong provision na naanay axial load or axial load na involved. So for part 1, compute the maximum value VUX using the simplified calculation for VC. So when it comes sa column, pwede siya mag-bend sa X or sa Y. So, na siya X direction na shear, na po siya Y direction na shear. So, gina-check na siya both axes, and gina-indicate po sa problem kung unsay ang gusto na ipangita. But first, let's solve for the effective depths, D1 and D2. So, duha siya kabuok kay if mo tanaw ka sa pa-X, lay imong D, and if imong i-rotate or ibalin mo imong ulo, malay pod imo ang effective depth. So, money ang shear along X and shear along Y. This is the dimension 450 by 600. And diri ang D2 and diri ang D1. So to get D1, 600 minus tong effective so to get D1, ang D1 kay extreme compression fiber to centroid sa bar. So ang given man kay dili siya from dili to centroid. So clear pa ang gihatag. So una na kay 600, then kuha nimo aning clear concrete cover. So dira siya padulong na siya dira, like nag-touch siya sa ties. So ang goal nimo kay makaabot ka diri. So napa may ties, so may minus 12 na pod. So nakaabot na ka diri. And last na lang jud na i-minus is half sa imong bar kay centroid man ka padulong. So half sa diameter sa bar na 28, and finally nakaabot na ka diri. So 600 minus clear cover na 40, minus diameter sa tie na 12, minus half sa main diameter na 28 equals to 534. So, same pod sa D2. So, 450 lang imong i-base. Minus ka o clear cover. Minus sa ties o minus half sa main diameter. So, you get 384 mm. So, another perspective pod sa cross-section is kani na kay VUX or shear along X and shear along Y. Then, naatong factored axial load na normal sa cross-section. So, perpendicular siya sa cross-section. 1,250 kN. So, mani ang given. And, ang gamiton nato na effective depth kay kung unsa ang perpendicular. So, first is VUX. So, ang gamiton na effective depth kung unsa ang parallel na dimension. So, since mo ni ang VUX, inani iya ang direction and ang parallel niya ng effective depth kay kaning D1. Therefore, D1 ang gamiton. So, NU is just equal sa PU na axial load 1,250. And since ang load kay towards sa cross-section, meaning compression siya. So, ang imong gamito na formula is katong with axial compression. So, let's find it. So, kani siya, 0.17 times 1 plus NU over 14 area gross times lambda square root of SC prime BWD. So, substitute all NU is 1 to 50 times 10 raised to 3 to convert to Newton over 14